Hi YouTube, it's csunplugged, and right now I want to show you my implementation of Bresenham's line algorithm of integers in Minecraft. This will take two coordinates in a Cartesian plane and draw a straight line between them by calculating an error bound of knowing when to increment or decrement a pixel on the smaller axis. I'll get into that in a second, but right now I'll just show you a line between 1.14 and 14.7. So what it'll do is it draws that initial point of 1.14, and then it's going to draw up until it hits 14.7, which is right there, I think, or maybe right there. So I'll just let that go and talk right now. It's putting one pixel on the screen every 3 seconds, which is 30 ticks, which is pretty slow for machines of this sort. For reference, Proper English 19 had one that did it every 12 ticks, and Newmaster, I don't know how, but he had one that did it every 8 ticks. So I'd assume they just had extremely fast adders, because Proper English had spoke about his streamlined comparator, but in my case at least, the comparator is right here, and it's only used once, and not only that, but it's never used in the loop. So this is actually an all-purpose comparator that I made solid state. Kind of funny how I made this solid state and then I went ahead and used piston based adders, which went back to bite me in the rear end because they stink. I hate them. But on the subject of Proper English and Newmaster's videos, they had both mentioned that theirs could handle negative slopes, and as you can see, this does have a negative slope. But the thing is, since this only has integers, it never actually calculates the slope, so it doesn't really matter what the slope is. While I draw another point, I'll get into how this thing actually calculates it. So I think I'll draw the line from the origin to the top of the screen. So the way this algorithm works is it initializes an error bound. Well, I should preface this with, there is a major axis and a minor axis, with the major axis being the larger one and the minor axis being the smaller one. And what it'll do is it initially makes the error bound 2 times the minor axis minus the major axis. So in this case, it's 2 times 15 minus 15, which is positive 15. And then it starts to loop over that value, the error. And what it'll do is, if the value is positive, it'll increment the minor axis and the major axis, and then it'll subtract from that error value the difference between the major and the minor. So that means it'll do error is assigned to error minus quantity, major minus minor. In a link I'll provide in the description from csunplugged, it had it say plus dy minus dx, where dy is less than dx, but it's much easier to think, oh, I'm subtracting a positive number than adding a negative. There's the line that's done. And then it'll loop over that. So in this case, it was 15, and so that's positive. So it would subtract what is actually 0, because 15 minus 15 is 0. So it was just stuck in that loop forever, always incrementing the minor along with the major. And the minor in this case could be thought to be the x, or the y, because they're both the same size. This is already 4 minutes long, but if you have any questions about this machine or this algorithm, you can let me know and I can help you. Maybe I can make a video about this actual algorithm in of itself, because one thing that was a pain in the rear to implement was the fact that this must handle negative numbers. Yeah, which is a pain in the rear, because if you were this, or the loop for mine implements 1's complement and 2's complement at different times, and if you know about those, during 2's complement, if the most significant bits carry out is positive, that means it's a positive number, I think, don't quote me on that, and then it's the opposite for 1's complement. So you have to think, am I doing 1's complement or 2's complement, to think, oh, is this a negative or a positive number? And that was just a giant pain in the rear. If I ever remake this machine, it'll definitely be pistonless, so it's going to be a lot faster and less buggy. But thank you for watching. This has been csunf with my line drawer, and I will see you soon.